Let's go to our first slides here so we can introduce speakers. So Bob, for those of you who don't know Bob, he has, as he just mentioned, over 30 years of experience in the EX world with these companies, ICX. He's also Source IEC, sorry, and he's a Comp EX instructor, assessor, and inspector, and he's also an inspector under the ICEX Comp PC scheme. He is also an inspector under the US UL STP scheme. It's been so for many years. We've done several webinars together, and he is very qualified for that. I am Paolo Andrini. I'm the BPOCL of GM International. Let me give you less than 5 minutes presentation on GM International, who we are, what we do, why we are here. So next, Bob. GM International is a safety company. We manufacture, design, engineer a complete range of intrinsically safe and certified devices for all automation packages from oil in various industries, primarily oil and gas, but also petrochem, pharmaceutical, food and bev, and so on. We have over 40 years of experience, and we're very proud to have our production here in our facility near Milan, Italy. On the other hand, we are a global player with presence in all the continent. Next, and you can see some of our offices here. We have several distributors. Next, because we make safety products, so we take special care in manufacturing them with state-of-the-art technology. We have 100% traceability testing. We offer 5 years warranty because at the end, we make safety products. They don't amount to too much in the overall cost of a plant, but they do provide for safety and availability of the plant. So they're quite critical items. So we try to make them as best as possible. Next. And of course, we have worldwide certification for them from, ICEX and all the others, UL, FM, and so on. Also, functional safety management certification up to C3 for our company and our product. ISO 9001, 45,000. We also have 18,000 now, and so on and so forth. So let's look at the product we make, which is our next slide. So, IS barriers, safety relays, with and without line monitoring. We have isolators, also SEAL certified, power supplied, SEAL and IS certified, multiplexer, temperature multiplexer, digital multiplexer, heart multiplexer, surge protection device. And we also offer services and training in the EX and SEAL domain. Some of our customers, you can, eventually we will send you to all the registers. We normally send a copy of the slides, so you can read through those. And so, because I looked at the webinar, Bob, it's quite, it's long. So I'm not sure we're going to stay in 1 hour. So let's move forward.
Okay.
And it's all in your end. Guys, if you have any question beside those that you have posed through the registration, which we will look at the end, there's only one way here. There is a question and answer. You can click on those and place a question and we will try to answer. Okay, Bob, next. I will try to.
All right. Well, thank you, Paolo. Hopefully you can hear me now.
Yeah. Now we can hear you.
All right, fantastic. Yeah, we had a little technical difficulties. We were freaking out, but fortunately we got it figured out literally about 30 seconds before we started this. So, well, welcome everybody to joining this webinar. We had a large amount of people that registered for this, and hopefully most of you are there. And in looking at kind of the people that have signed up, I see it's a lot of design engineers, and usually design engineers are the folks that are really involved in, obviously, selection of intrinsic safety products and involved in DCS or fire and gas systems. And of course, EX inspections, obviously, many of you are involved in the petrochemical industry, and EX inspectors usually come in at the end and they create all kinds of problems. And one of the things I've always felt very strongly about is making sure that even if you're a design engineer or a controls engineer, you should know, at the very least, what is the role of the EX inspector that's coming in. It could be within your own organization. It could be a third party. It could be, whomever, the client, or if you're building skid packages or whatever, really understanding what they're trying to find out, what is the basis and the reasoning behind all this. And then we'll kind of do some examples of maybe some pictures of some issues that you may or may not be able to catch. And then certainly, as Paulo said, we had some great questions that were asked, and so we'll have some time at the end to kind of go through all that good stuff as well. So why is it important, right? I think we all understand that it is truly very important that we do inspections, because inspections is just part of the chain, if you will, to make sure compliance and making sure that the installations and the equipment are reliable and safe, and that we don't have, either large industrial accidents like what we see here, or even just smaller ones that might, cause downtime, lost time accidents, and all that good stuff. The other thing that I think that gets lost in this is that, proper EX inspections also, when done early on, can also save clients a lot of money. You don't have to worry about doing so much rework on things, or having that final inspection come in and then delay shipping it out because now all of a sudden we have to fix this or take care of that. So if we can be more cognizant of the issues ahead of time before we're actually ready to do things, I think it can ultimately make it both safer and certainly much more cost effective as well. So the relevant standard that we really follow, and this is true pretty much anywhere in the world, we follow the basics of IEC 60079-17. I know many of you are probably manufacturers, and you may be building equipment to relevant IEC 60079 standards. But the 17 is the one that is really our Bible as an inspector. We follow this, we use this. Almost every oil and gas company out there is using this as the basis for their own inspection tables. So it's important to understand. And then if we look elsewhere in the world, within Europe, the EN standards are more or less copied directly from the IEC-17 standard. Here in the United States, we've actually now written a UL version of this, and this will apply to class and zone applications. In Australia, we have an ASNZS, and in other parts of the world, Brazil has their version of it. They're all very, very similar. So if we get familiar with the -17 from the IEC, then the good thing is we've covered probably 85% of what we really need to know. However, when doing inspections, it is important to understand that, using the 17 standard is great when we don't have anything else to go on. However, the 17 is somewhat limited. It covers broad strokes, and it's a minimum requirement, if you will. Many oil and gas companies, many clients will go above and beyond and require additional inspections, or maybe some of the criteria may be different than what's spelled out in the -17 standard. I can tell you from my own practical experience doing inspections, coming into a facility, that's the first thing I want to find out. What is the end client's requirements above and beyond the requirements from -17? Because a lot of times you can find some things that are spelled out in 17, but maybe not that clear. But then all of a sudden we start looking at maybe a client specification, and then they spell it out. They say certain things that it must be this way. So we want to make sure when we're doing our inspections to understand, realize that the -17 standard is a boilerplate, but it's not the end all be all. We really need to follow what either the legal requirements are in that particular country, or a end client specification that may call out something above and beyond. So what do we need to know before doing an inspection? We don't just show up and say, show me the equipment and let me go take a look at it. There's a lot of things that we have to have ahead of time before we can truly do a good detailed specification, right? We need to understand what are the country regulations and what are the client specifications, first and foremost. What type of inspection shall we do, which we're going to talk about here in just a little bit, either visual, close, or detailed. We also need to have a bill of material, what's on the drawings, copies of the drawings. Ideally, we want to have certificates for every piece of equipment that's on there. We also want to have an EX register and data sheets on all the equipment, including installation and operation manuals. Many times, what slows down this process for inspections is not having access to all this information. So if you can collect a lot of that information before an inspector comes in, then you know you're taking care of about 90% of what that inspector is really going to be looking for. In some cases, we will have to spend time, and I've done this many times, where I'll actually build that EX register, or I'll have to go collect the certificates, and I'll have to go get data sheets, and then I have to start reviewing it, which just, again, adds time and money. So the more that you can do to get all that information together ahead of time makes it so much simpler. One of the things that's kind of overlooked, and it's kind of simple, but what is the area classification? I can't tell you how many times I've been into facilities where they say, or a subcontractor is building something, they say, hey, I want it suitable for zone 1. Okay, what gas group? Well, I don't know, it's zone 1. Okay, well, what about the T codes? Or what about the gas groups? Or what about the ambient? You know, all of that type of stuff. We really need to understand the specifics of what is a requirement, right? And then one of the last things on there, the listing of all the X conditions. If you've been part of these webinars in the past, we've spoken about U and X conditions on certificates. X conditions are conditions for safe use. Anytime that we see an X at the end of a certificate, that is going to give us, if you will, some further information of how that particular product needs to be installed in order to be safe. And it's critically important that we see that information and make sure that we compare whatever those conditions are to how it's actually installed. And I can tell you, there have been many instances where people have X condition equipment. We go and do inspections and we find out that the X condition is telling us it has to be installed in this fashion or in this type of location. And all of a sudden, it's not done. So it's really important also, if we're designing systems, that anytime we're incorporating EX equipment, to take a look at vendors' X conditions, because it can make a big difference. I'll give you one quick example. Transmitter company that shall remain unnamed had an X condition in which their transmitter had to be installed in order to meet the conditions for safe use in an area in which it would not be subjected to potential impact. Well, unfortunately, they had installed all these transmitters in areas that were exposed to direct impact. So in that particular instance, they had to either move the transmitters or actually build some little protective lenses, if you will, to cover them up to meet the requirements of the X condition, which again cost a lot of money, takes a lot of time. So we want to be very much aware of that. And again, without this information, it's like driving to some place where we just don't know where we're going, right? Yeah. So again, the standard is the -17 standard. Again, the EN standard is virtually identical. There are different types, and there are different grades of inspection. And this is also important to understand. So a visual inspection is just literally going out and taking a look at some equipment that's been installed. We don't need to have any tools. We have a visual look at it. This is going to tell us things like maybe there was some unauthorized modifications, or maybe the environment. Maybe it's in a very corrosive environment. We're seeing that things are starting to rust in a significant fashion. Or maybe there's a damaged lens to a light fitting. These are the kinds of things that we would typically pick up under a visual inspection. Generally speaking, the qualifications for individuals to do visual inspections isn't necessarily that onerous. It's more of a walk around within your facility, and it could be your normal maintenance people that are actually, while they're doing their work, are going around and just looking at it. Now, when we get into a close inspection, the difference here is close is that we're now starting to use tools. So we may take a step ladder, we may take a flashlight, we might use magnifying glasses. So now we're actually getting up close and personal. this is where we're going to start looking at things like maybe the labels, or we're going to look and check and see if cable glands are nice and snug. We don't want to open up a cable gland if we find that it's loose, but we want to go ahead and touch the product. So this is a close inspection. A detailed inspection is that now we're going to open up this equipment and we're going to have to go through our lockout, tagout procedure, making sure that we have our gas-free permits or whatever the requirements are in the facility. Or if we're at a subcontractor's facility and it's not energized, generally we can do those detailed inspections right away. At this point, we're starting to look at internal faults. We're going to start looking at maybe the flame paths. We're going to start looking at the equipment that's installed, maybe the gaskets. All of these types of things are going to be found under a detailed inspection. It is a requirement, and this is important to understand, that before equipment is put into service, it must undergo a detailed inspection. Now, it doesn't say, the standard doesn't tell you that it has to be done necessarily by a third party. It could be done at the manufacturer's location. It could be done once it's shipped and once it's installed. It could be done at both locations. But before it gets energized, a full detailed inspection must be done on all EX equipment. Now, there's also inspection types, if you will. There's that initial inspection. That initial inspection is basically a detailed inspection. Then we have other different types of inspections that we have: periodic, sample, and continuous. So periodic could be a routine basis where it's in our facility and we go out and we say, we're going to check all these lights in this particular unit on a routine basis. Maybe we'll do this unit this month, the other unit a following month, and so forth and so on. A sample inspection is where we're basically saying, hey, we're going to go see how this equipment is holding up in the environment. We might say we'll determine a sample size. It might be as little as 5% of similar type equipment. And we're going to go and do maybe a visual close or even a detailed inspection. And if we start seeing issues under a sample inspection and we see that there's problems, then maybe we say, hey, we're going to go ahead and go ramp it up to a full detailed inspection on a larger sample, or maybe every piece. That's usually left up to the discretion of the plant operator owner. And then continuous. This is more where if I've got a maintenance group that's doing some work on a motor, it's an EX motor. Hey, while we're out there, let's go ahead and do a visual or close inspection on that motor to confirm that everything is A-OK. So there are some inspection charts that are published within the standard. More or less, there are three major charts within the standard, or columns, if you will, within the standard. There's one column set up for D, E, and N type equipment. So flame-proof, increased safety, and non-arcing, non-sparking type equipment are all within one schedule. There's a separate inspection schedule for intrinsic safety, and then there's a third inspection schedule for EX pressurized. Other protection concepts, such as oil immersion or sand or quartz filled or other types of protection concepts, we typically will follow the one or more of those inspection charts. Or in some cases, I've seen people actually build their own inspection charts for their own specific requirements around the EX protection concept. Many of the other protection concepts, like encapsulation and some of those, are actually more on a component level that will be part of a D or E or P type system. So here's an example right out of the standard, the inspection schedule table 1A. If you look over under A, that applies to all equipment. And as we go down this list, you'll see, what are we looking for? And over on the right-hand side, we look and see there's a D column, there's an E column, and there's an N column, and T for dust applications. So if we're looking at a piece of flame-proof equipment, we want to check and make sure is the appropriate to the zone requirement of the location. Now we can find this either as a detailed, close, or visual. You'll see the check marks. But when we start looking at some of the other details, some of the things within the inspection charts, we would only find them as a detail. Say, for example, is the equipment internal appropriate or does it match the drawing? We're only going to find that once we open up the panel. So we're not going to find that in a different fashion. So that's an example. Then in B, there's an installation section. So now we've looked at the equipment. Now we're looking at the installation. Is the cable appropriate? Is there damage to the cables? So forth and so on. Stopping boxes and cable boxes are correctly filled. This is seal fittings and cable glands. This is all part of section B. And then finally in C, that's the environment. Is it protected against corrosion? Is it clean? Are we having all kinds of issues? This might be more of a situation after once it's installed. That's going to be more from a maintenance perspective, but certainly from a design perspective, we have to take that into account when we're designing our packages or equipment. So conducting an inspection, what are the things, right? The knowledge, skill, and competence of an inspector is critical. It's obviously very important. What is the scope of the inspection? Are we talking about just a small portion of this? Are we doing an entire facility? The type and grade of inspections to be conducted. Again, our documentation. Availability of facility personnel to exist or assist. If this is an energized, or we're going into a facility in which it's got energized equipment, as an inspector, I always recommend we're not actually opening up the equipment ourselves. We want to make sure that the plant people are doing it. We don't want to be touching things, inadvertently hitting an e-stop button or doing something like that. We want to make sure that we have a facility personnel that's going to join us to help us out during this whole process. Obviously, availability to de-energize lockout for our detailed inspections. Access to equipment. How are we going to actually access some of this equipment? Are we going to have special lift equipment, or is it located in an area which is just very, very difficult to access? And then the types of equipment, and then of course the environmental conditions. These are all the criteria that we need to take into account. Here's the important thing, right? Safety is the utmost priority. As an inspector, we should not be biased. We shouldn't do anything that goes against what you feel is appropriate, right? Do not compromise safety by doing anything or doing any of the following. Using equipment, right, within a hazardous area that's not suitable. The inspection that you see on the right, it will be a zone 1 area, but this was not energized and the gas was not present. But I actually was using, in that case, a zone 1 tablet, a zone 1 RFID reader to check out some equipment and actually building a register in that particular instance. I made sure I wasn't bringing in anything that was potentially could create an arc or spark. Opening up equipment without a gas-free permit, never do. Again, operating any of the controls. And again, here's the important thing. If you think it's unsafe or it's incorrect, it's always right to write it down. Put it down. Don't let anybody talk you out of that. Make sure you write it down. If you're unsure, it's okay to write it down and then go back and look at drawings, look at certificates, look at the documentation, talk with your colleagues. Make sure that anything that you see out there that if you think it's unsafe, make sure you record it and try to make sure that we do this, because if we think it's unsafe, then it very well may be, and we don't want to have a situation where people are hurt or killed based upon us not thinking properly.
Okay, Bob.
Oh, we have our first poll question.
First question. You know, I've been quiet because I've been listening to you. It's a new webinar and it's interesting. Guys, which one of these is not a grade of inspection? Let me give you a hint. You know, one of them is just one, you know, offspring is not a grade of inspection, is a type of inspection.
That is correct.
Yeah, right. So I've been listening and, you know, it's just why our guests are voting How about answering a question? I saw the tables that you were using. Are those available? Are those
Yeah,
in the standards?
yeah, they're in the standards. And if anybody would like a copy, I've taken that information and I've put it in an Excel spreadsheet that we use. And there's also inspection software. We work with a company called Arn Lee that manufactures EX inspection software, that they have it within their software as well. They're all based upon these inspection tables. But yeah, they're right in the back of the -17 standard. But if anybody would like to actually have a copy, we do have it available in Excel that I'd be happy to share with anybody out there.
That's great, guys. So just write an email after the webinar and Bob will share those tables with you. How about the great visual required to check if the equipment is okay for the location, but does not require to check if the group is okay? I'm not 100% sure about the question. Line 1 and 2. I guess we have to go back to the table.
Yeah, I'm not sure I understand the question.
We will look at a little later on. Okay, let me terminate this. Let me stop everything is in Italian. Everything has changed. You know, the software has changed. Everything has changed. Okay, now I have it in Italian, no longer in English. Failed to share poll. Another poll has started. What happened, Bob? Are you playing with the webinar?
I just shared it. Did I?
Okay, so you are playing with it. Okay, great. So most of you answered correctly, right? It was initial.
Yeah.
Which is a type of inspection. The others were visual, close, and detail.
That's right. Those are types of inspection or grade. Yeah, those are grades of inspections. A initial inspection is a type of inspection. So this is actually one of the questions that usually comes up during either Compex training or IEC, EX, COPC training. So yeah, anyway. Okay. Well, good job. Most of you got it right. That's good. All right, I'll close that. We'll continue on. So let's get into some of the details here on some of the some equipment that you might see out there, and some of them are pretty obvious. But here's a good example, and of course, we're not going to actually have you go ahead and chime in, but we'll give you a second just to look at it. But what we have here is a flame-proof enclosure that obviously the bolts are missing. So would this be something that we would be able to identify probably as under a visual inspection? Yes. We would obviously, at this point, we realize that this enclosure is not safe. We would certainly take note of that immediately and go from there. I have not seen this, but I actually had a colleague, and I wish I had a picture of this, but I had a colleague one time on flame-proof enclosures. It was a very, very large enclosure, bigger than this one, in which all the bolts appeared to be installed properly. But when he went to go and look at it closely, actually there was only 4 bolts installed in all 4 corners, but somebody had decided to cut off the bolt tops and glue them into the other openings to make it appear as if you had bolts all fully installed. So that was a situation in which obviously somebody was just
let me ask you a question, Bob. Maybe you can answer the question of our customer. So if we're doing a visual inspection and we're looking and we see this box, would that lead us to go to a detailed inspection, close inspection?
Well, at this point, yeah. What we typically say, if you find a fault, well, as an example, let's just say hypothetically, this was maybe it's a zone 1 area, right? And it's requires a 2B gas equipment. And I look at the label, I'm doing a close inspection, and I look at the label, and the label says it's EXDB under the new marking requirements, and it's 2A. Well, 2A is not suitable for 2B gas groups. That immediately tells me that product, I don't need to do any further inspections on it because it needs to be removed, right? So if the product is not suitable for the environment based upon either the temperature code, the gas group, or something like that, I really don't need to do any further investigation on that. I'm going to move on. What I am going to say, though, this product needs to be removed and replaced with a product that is suitable. Now, in this scenario, what I would end up doing is, yes, I would end up doing a detailed inspection on the inside to see if there's other issues And what you may find is maybe some equipment is, well, we'll talk a little bit more about that, what you might find on the inside of flame-proof enclosures, what you're really going to look for.
Okay.
So here's a pretty common one. The people typically, I've seen this so many times, and this is not my picture. I think it was actually came from one of the IECEX presentations, but basically the use of Teflon tape. The requirement in the standard or the installation standard is basically to use a non-setting grease, a non-hardening grease, some sort of thread lubricant. Now, the way you would actually find this on an inspection probably would not be under visual, because the shroud was actually probably all the way up over the cable gland, in which we could not see that Teflon tape. However, if we did a close inspection, part of a close inspection is removing those shrouds, sliding them back, and that's where we would have discovered the fact that we had Teflon tape. So the remedial action here would be, obviously, we have to disconnect the wiring, we have to remove that Teflon tape, replace that Teflon tape with some sort of non-setting grease, replace the shroud, and go from there. So again, you might not be able to identify that as a visual inspection. It's probably something you'd find under a close inspection. And this is pretty common. We see equipment that comes out of the factory. In many cases, they'll have what they call a traveling plug, which is a temporary stopper, if you will. It's non-EX. And this is very commonly installed on pieces of equipment. It's more or less to keep dust and contaminants from getting on the inside of an enclosure during transit or during that initial installation or what have you. But unfortunately, in this case, it was installed and it wasn't replaced with a certified plug. And by the way, this particular device had been in service for about 3 years before it was discovered. So again, we should identify that immediately and realize, hey, this is an unsafe situation. If we had an explosion on the inside of that transmitter, that traveling plug would not do you any good, and we would have a major catastrophe, assuming there was flammable gas surrounding that transmitter. Now, this one could or may not be a fault. What you see here is you see a flame-proof enclosure, but you see plastic glands. And plastic glands generally are, you can find EX certified plastic glands, but they're generally EXE, increased safety. They are not D rated. If this device was actually wired up and used as intrinsic safety, you could potentially argue that you might be able to use plastic glands, but in reality, you would have to use a gland that's suitable for the protection concept of the enclosure. And since that is a flame-proof box, we would want to see flame-proof glands. So in reality, this is an issue. Now, this is a common issue as well. If you look at this label, you will notice there's, I think at count here, you can see there's, it's rated EXD, it's rated EXIA. For gas applications. It's also rated EXIA for dust applications, and it's also rated EXNA non-arcing. So we really have to understand how this is being installed to understand which certificate is going to be the certificate that's going to be the valid certificate. And notice at the end of the certificates, if I can do this real quick, I'll try to. Notice around here, you see an X, and there's an X there, and there's an X there. That's what I was talking about earlier about a conditions for safe use. So we want to see that. We want to see the appropriate cert. And as a good example, I've done this where I've gone in to look at equipment, and then I'll get a cert, but then this piece of equipment might have 3 different certificates, and the cert that I got didn't match up how it was properly installed. So we want to make sure that we've got the right certificate depending on the product. And manufacturers are doing more and more of this because they want to have one product that can be used for many different ways or for many different markets. So you'll see nameplates that will get extremely confusing. But this one in particular, This is ATEX, but you actually have 4 different ATEX certificates on this. So even though it's ATEX, there's still 4 different certificates, and we need to make sure that we understand which one we're looking at. The fault here, right? This is a barrier gland in which the compound is cracking. We would not find this under visual or close. If you find that a cable gland is loose and you go up to it under a close inspection, here's one thing that we fail students when we teach them either in COMPEX or under the IEC EX inspection schemes, that if you actually start disassembling the gland, it's an automatic fail. And the reasoning for that is that the moment you start tearing apart the gland and you have not gone through your lockout tagout procedure, or you haven't confirmed that there is a gas-free environment, at this point, you have now basically invalidated any EX protection of this particular gland and this system. So it's critically important that we don't go in and just start removing glands without doing a detailed inspection, going through our lockout tagout procedure. Now, what is a good hint, if we find cable glands that are loose or look like something, then certainly that's going to be something under our visual or close inspections. We're going to want to take a closer look, and we are going to want to open them up and check for things such as this. Here's an issue where we have some IS connection points that are not properly terminated. You also see some cables that are clipped. You know, that is certainly not acceptable. We have a lot of copper showing. This is definitely an issue that would need to be addressed. We also have some screened armored cable that's just sitting out there. So there's quite a few little issues here. We would typically find this under a detailed inspection, right? This is going to be inside of a panel. We're going to want to look and check all the wiring to make sure it's appropriate. If it's intrinsic safety, we want to make sure that intrinsically safe wiring is separated from any of our instrumentation wiring or power wiring, all of those types of things. Here's a big issue. Nameplates, labels. In many cases, and I have a bone to pick with certain manufacturers because some of the labels that they will put on their products will not last more than 6 months in the field. And this is a huge issue. It's very difficult, and the requirement is under the standard, is the equipment appropriately labeled and identified? And if a label is disappeared either due to corrosion or it's torn off or what have you, we have to address it in some way, shape, or form. You know, generally speaking, the best approach is to go back to that manufacturer and ask them for a new label. But there are other ways that we can address that, but it does need to be marked that we know what this product is and that it is appropriately marked and labeled. The issue is that we obviously have an environmental issue where this is leaking, and we've had a lot of water accumulate on the inside of a light fitting. So therefore we would find that generally under a detailed inspection. Again, we're not going to open this up under a visual or close. We might realize that the light is not working. We want to go and find out exactly what it is. So we'll go do our lockout tagout, do our gas free, and then start opening it up. And then we realize, well, in this particular instance, we had obviously either condensation or leaking from the glands in something like that. So again, going to have to fix that. So coming back around, and you guys should all understand this one. I don't expect any of you to miss this question. What standard do we follow for EX inspections?
Well, any of you but me.
I highlighted this. You know this. You know this.
No, I saw it. So let's give it a few moments, guys. What standard do we have to follow if you are to look for inspector? If you want to become an inspector, and or you have an inspection coming, you want to know what's coming to you, you know?
Right.
You have to look at the standard.
I'll give you some hints while you guys are answering the questions. The 79-1 standard deals with flame-proof equipment. The 10-1 standard deals with area classifications for gases and vapors. The 14 standard is an extremely important standard to understand, but it's actually the design and maintenance standard, or actually design and installation standard. The 17 is actually maintenance, inspections and maintenance.
Yeah, you're right. And I have to say, not most of our friends answer correctly 17, all but.
Most of you did. Most of you got the right answer. That's important. And there's always a question, because we also do teaching of various competency programs. If you more or less follow the requirements out of the -14 and -17, that's really where the competency programs majority of the information is going to be coming out of those two standards. All right. So did we share results?
Next. Yeah, we share the result, the sort.
All right.
We can move forward.
So we just have a couple more pictures of this, and then we'll get into the Q&As. What's the fault here? This is a difficult one. This is a damage to a machine surface, right? And machine surfaces for flame-proof boxes have what they call maximum experimental safe gaps, and we typically identify that by the use of feeler gauges. But obviously, in this case, we've opened up an enclosure and we've seen a big gouge on the face of the flame path. Now, this is a tough one because flame path products are very expensive, and is this a dangerous situation? I would say from a practical perspective, I would say that this is not a dangerous situation. However, I wouldn't necessarily feel comfortable in having that as part of a flame-proof box. If we saw a gouge that was traveling a good length going the opposite direction, meaning that if we had a gouge or big indentation coming in like this, or something like this, or even something that goes all the way across, that's obviously a very dangerous situation, because a hot flaming gas, if we have an explosion on the inside of here, that's a path for that hot flaming gas to get on the outside and explode. So in this particular scenario, because we have this gap right in here, we still have a significant portion of good flame path. But because that gap was there, I'd be very concerned that maybe this was milled improperly. Something came out of the factory. And if it came out of the factory like this and I received it, I would absolutely send this back to the manufacturer. This is pretty obvious. You have a lot of accumulation of moisture, water building up on the inside of some flame-proof products. So obviously not a safe situation, and we would find this under a detailed inspection. Here are cable glands in which we've now gone into a full detailed inspection. We start disassembling them, and then we start seeing that the armor has not been properly secured to the internal cone on these cable glands. So again, we would find this under a detailed inspection. What might give us a hint is that when we're going around and touching these glands, we might find that maybe the back end is a little bit loose. We find that out on a close inspection. But again, we'd want to start off with a detailed, or maybe do a sample inspection. And if we see one gland like this, then we're going to open up some others. And if we find, in this case, 3 glands like this, guess what? There's glands right behind them that have shrouds protecting them. I would open up every single one of these glands, because I can pretty much rest assured that if these 3 are wrong, then most likely, probably everything else is wrong. Here's an issue actually for sealing, if you will. Somebody had just taken some extra compound and packed it around a big conductor that was passing through a flame-proof box. It had a gland on the outside. So from the outside, it looked fine, but now all of a sudden we've done something that is certainly not appropriate. And again, we would find this under a detailed inspection. This is a pretty common issue. What you find here is that at the very end of this certificate number is a U. You'll see it under the IECEX certificate, and you'll see it under their ATEX certificate. What that U is telling us, it's actually a component, meaning that this manufacturer supplied this enclosure empty. Then the client went ahead and put terminals on the inside and just figured, hey, I'm A-okay. Well, as an inspector, anytime that we see a U certificate, immediately at that point, it is a fail, because this is now a component and it's not a full assembly. That's different from finding, say, a U component on maybe something that's inside of an enclosure, such as maybe a control switch or something like that, that might have a component cert. If the enclosure includes that component switch on its overall certificate, then I'm okay with it. But if I see an enclosure with a U certificate, that's immediately a red flag. And we would find that under a close inspection. This one could be IS and non-IS. We have a mixture of both, and there is not a segregation between the two. Again, detailed inspection. This is actually from a barge explosion that took place here off the coast of Corpus Christi here a couple of years ago, and this was the state of the explosion-proof boxes that were. This did not happen because of the explosion, but the explosion took place pretty close to this, and this was actually one of the things that we found, that the seal fittings were not properly installed, or in some cases they were just not maintained. And again, you would see this under a visual inspection. And again, the point is that if we're going to spend all this money on this very, very expensive flame-proof box, and yet we're not going to use the appropriate seals, or we're not going to install them properly, then why are we spending all the money in the first place? Because this is the weakest link. We're going to have all kinds of problems. Here's something where a gasket has actually come out of its seating, right? Usually flame-proof boxes will have O-rings machined into them. We cannot put O-rings on flame-proof boxes unless they're specifically designed for them. And if it's a flat flanged box, it's going to have a machined surface in which this gasket is seated. And again, this is something that's fairly common. We would find this under a detailed inspection. Now, I threw this in here because what is the fault? Well, just by looking at it from this point of view, it's a flame-proof box with a lot of components. Do we know that all those components that are installed?
Oh, yeah, you are.
Point, oh, yeah, you hear me?
Oh. Yeah, you were out, or maybe I was out. I'm not sure.
Oh, okay. I apologize if I cut out, but here's an example of an enclosure in which it has an awful lot of components. Now, we could look at this and we say, okay, well, I think it's okay. We might look at the wiring and do all that good stuff. But what if maybe they've replaced some of those components with other brands, or maybe there's more of them than what was originally supplied from the manufacturer? So it's important when we do our inspections to not just have the certificates for the products themselves, but we need to have drawings. We need to have a bill of material. So when we go and look at a full panel like this, we want to double check to make sure that everything that came out of the factory is basically the same as what's actually there. If we start seeing additional components on the inside of these enclosures, that's a red flag. We don't want to see that type of stuff. We don't want to see people adding things to these enclosures in the field without evaluation, without further evaluation, and it may require fully to recertify that product depending on how it goes and depending on what the manufacturer allows in that particular panel. So it is important to understand you need to have drawings. You need to have that information. Again, if you don't have it, then you really can't do a good job. You also need to have this register, and this is what a register would typically look like, right? So we'll build the registers ourselves, or hopefully a client might have it. You'll have tag numbers, description, certificate, and all these others. And these can go quite a few more cells. But this will tell us exactly what should be there, what's its certification, what the IP ratings, is there an X condition, what are our ambient conditions. It's kind of a nice way to be able to have a lot of information all there ahead of time and use this as a basis when we're doing our inspections. And this document should be available, this register, for everybody within that facility to be able to look at, our maintenance people and everything else. So if we're building an EX skid package that involves a lot of EX equipment, you absolutely should be building an EX register, and it should be in some sort of format that looks like this. Again, some of the tools that are available, I mentioned I showed a picture earlier, but there's an example of a Zone 1 tablet that has the inspection software built in. There are things like RFID tags that are certified, and then you have barcode readers, or you have RFID readers. There's all different kinds of tools that are available out there, especially if you really want to get into it. If you're a facility owner, operator, there's ways to automate a lot of this stuff. And the one nice thing is that if you do actually have, say, for example, during that initial detailed inspection, you capture all that information. When you go to your tablets, you can actually pull up all the certs, you can pull up the X conditions, you can pull up all the information. It makes inspections go very, very, very quick. And it makes it easier on inspectors. So I highly recommend it, especially if you have a lot of EX equipment that you're responsible for as far as your assets.
And we have one last call today about protection concept. So which one of these do not have any special schedule chart? Oh, I didn't see the chart before. I don't remember this one. So we have flame proof, increased safety, encapsulation, and pressurized. I would think, if I just throw, out of blue, I would say encapsulation, because you cannot actually open it, so you cannot see inside. I don't know whether that is correct or not.
Well, that's a good guess.
That's a good guess. Okay.
It's a good guess, and you're correct. So the inspection.
And in fact, you guys, we move forward because we are getting close and we want to answer some questions. So yes, you also have answered correctly. You guessed correctly, or you knew.
Yeah.
What is the answer? Okay, it is encapsulation. So, Bob, we do have, go ahead, complete the webinar, and then we go into some questions.
Again, some of the things to take away, and we'll go into some question and answers. If you think it's a fault, write it down. Become competent, right? Go through a competency course to understand more. There's the IEC competency program. Here's the other thing. I've done a lot of inspections, but even with somebody with my background, I hate the term expert, subject matter expert. I know an awful lot, but I'm not arrogant enough to know that I know everything. You will see things that you have not seen before. Engage with other people, and don't assume anything, right? And again, don't let outside influences affect your judgment. Regardless if you're officially inspecting equipment, be an inspector, right? Do it. Get used to it. Again, if you're designing systems and you're get an opportunity to go down on your shop floor, go down there, take a look at it, go get those charts, go see what your people are putting together. If you're installing things, right, inspect your own work, right? The more that we get involved in inspecting, then guess what? We catch more of these problems before they become major issues. And again, the last thing, stay on top of your game. Standards are changing. There's a new -14 standard, design standard that's going to be a lot of changes that's coming out next year. These standards are constantly changing. Always make sure you stay on top of it. And again, safety begins with you, right? So with that, we're only as strong as our weakest link. Don't be the weakest link. Now, with that being said.
So, Bob, we have some live question, and we have our question and answer, which we prepare. Maybe you want to go for the live question?
Yeah, let me bring the other
I brought this up. I don't know if you can see it. In the meantime, I work on the secondary presentation. Okay.
Oh, okay. If you want to bring that up, great, fantastic. Yeah. And actually, Paulo, I'm not seeing any of the questions.
You don't. Okay.
Well,
the first question it was. Let me go to. Hazardous area classification drawing is key reference. What is inspector involvement to ensure correct and completeness of the drawing?
Yeah, so as an inspector, well, what we want to find out, and we want to see on the drawing, what is the gas group, what is, and that's almost, well, we're always going to see the zone, right? Almost always on your area classification drawings, you'll see the zone. Is it zone 1, zone 2? zone 0, so forth and so on. But we also want to have a table on there that states what is the specific gases or gas group. We want to understand the T codes. We want to understand the ambient conditions. It doesn't, if we put that over on the side or actually within it, that just makes it a lot easier for us to understand as an inspector, right? More times than not, we don't see that on our area classification drawings, but it really is important to make sure that we have that.
Another question says, I don't know if you can see in there now, I made some changes to the setting. On equipment packages, when requested for electrical certificate for any individual electrical electronic component, it's been observed that package supplier covers by saying it's part of the overall equipment certification. Is this acceptable? Who is responsible for the certification of the overall equipment?
Okay, so if I understand it correct, Paulo, so you have a collection of EX equipment, and it's part of as part of an overall package, right?
Yeah.
So there is actually under the IEC EX scheme, there is a new technical specification, and it's 60079-46, and that applies specifically to packaged equipment systems. And what it's looking at is now here's the important thing to note about it. If, say, for example, I have a flame-proof motor starter, but maybe it's not IEC EX, and I'm trying to get IEC EX on the entire system, that standard is basically saying, hey, everything on there should be IEC EX. Now, there is a little get-out clause in there that says, for example, if I had ATEX on maybe a transmitter or a flame-proof box, but everything else was IEC EX, I can actually get IEC EX on the overall skid, but it has to be assessed against the latest standard. That flame-proof box that was built to the ATEX directive would have to have a gap analysis done by, in this case, an IEC EX certification body. Then a new certificate would be issued for that entire skid.
So an overall certificate would be acceptable, and yeah. And he's the one who's responsible for the certification is the guy who's actually issuing, the manufacturer.
That's right. And where this is coming into play, Paulo, is there are new 80079 standards for mechanical equipment, 36 and 37. And these standards are also part of, there is no inspection schedules now published yet for those standards. But if I'm building a skid, I'm very likely going to have a combination of mechanical and electrical equipment combined. I have to do what is called an ignition hazard assessment on all my mechanical equipment as well.
This is it's a question to an answer. It's the answer to a question we also got. Says if there was an inspection list for EX mechanical equipment.
No, not yet.
Not yet.
Not yet.
Not yet. Okay.
I expect the latest edition of 17 will actually include that.
We have to follow the latest standard, the latest edition, correct?
Well,
or the date of the edition that was at time of installation.
Yeah.
We do an inspection.
Yes, we should be following, well, whatever it was at that date when it was installed, we would follow that edition of the standard, right?
Okay. Even though it has maybe expired, that is being replaced.
That's right. If it's, I mean, because you could be going into a facility that's 10 years old, we wouldn't want to follow the latest standard, right? We want to follow the standard in which it was built. So we want to make sure and confirm when it was done, as opposed to new equipment, which would be to the latest standard.
Well, that means we have to keep a lot of books.
I have copies of EX standards going way back. Not that we get involved here in the States on old existing equipment, because we don't have installations that are around either ATEX or IEC EX that are existing.
I'm sure we're going to be able to get in our prepare answer, because we have a lot of live questions. There's another one here that says, you have concentrated upon the inspection of equipment is being suitable for the air. So the equipment is okay. What check tests are required for the cabling, for the interconnecting cabling?
Yeah, so cable doesn't fall under the scope of certification from an EX perspective yet, with some exceptions around the world. what we are checking for with our cable, within the Dash 14 standard, it gives us some parameters of the construction of the cable. And it'll say things like it should be round, it should have extruded bedding fillers, it should have, and whatever fillers there are non-hygroscopic, meaning non-wicking. But basically, that's what the Dash 14 standard is telling us. Now, there are exceptions to that, depending on the protection concepts and all that other good stuff. But what we're looking for from a, just in generality with cable glands and everything else, with cables and cable glands, generally speaking, cables are going to have a requirement from a client specification that they may require a flame retardant or flame resistant or halogen free standard. And there's a bunch of IEC, EN standards that are published for those particular requirements, and BS standards, UK standards. What we're going to look for is the gland appropriate for that cable? Are we using a non-armored cable gland with armored cable? Okay. Are we using armored cable with, so forth and so on?
Yes.
Is the diameter of the cable gland appropriate for the cable? We don't want to build up cable by using heat shrink or tape or something like that. We don't want to do those kinds of things. Is the cable properly secured? Meaning that some glands will have an X condition in which the cable actually has to be secured within 300 millimeters exiting the end of the cable gland. So we want to check those X conditions for those glands, because some glands will state very clearly in there that in order to be certified, this cable must be secured within 300 millimeters, meaning that we have to put a cable tie, secure it to a piece of structure or something like that. So those are the main things that we're looking for with cable glands. Are we using the right accessories, IP washers, earth tags, lock nuts, all that good stuff? Are we not using too many adapters and reducers? All of that good stuff. We don't want to see more than one adapter reducer.
It has to do mostly with how the cabling is going into the box or out of the box rather than the cabling itself.
Yeah. I mean, you are looking at things like bending radius of the cable. So that is part of our installation inspections as part of B, that if we see a very, very, very tight bending radius, that's going to be a question. Then I'm going to have to go back and look, okay, is this cable being bent too far?
Yeah. We have a question a little different, but maybe it's interesting to answer. Is there any reason why ICX does not have a conformity mark? Like ATEX, you have to have a CE marking to ICEX is not.
Yeah, that's an interesting question. I hadn't really thought about that. I mean, under ATEX, the CE mark is basically, the CE mark is telling you that your product is in compliance to one or more directives, all those different directives. And the CE mark in and of itself doesn't tell you it's suitable for hazardous locations, but it's basically that manufacturer's declaration. Under IECEX, there is no real manufacturer's declaration. It is either a certified product by an independent certifying body, or it's not. There is no, I'm going to self-declare something to be compliant with IECEX. Under the ATEX directive, we can, for zone 2, zone 22 pieces of equipment, we can make a manufacturer's self-declaration that this product is suitable for a zone 2 environment. We don't have to engage with a notified body unless it's zone 1 or zone 0. So that might be the reason. There is no self-declaration under IECEX.
Okay, how about this one? The description of cable in 79-14 are very rough, round, and so on. The correct specification should define the cable standard number applicable.
Well, yeah, within the Dash 14 standard, it really doesn't say anything else about fire and halogen requirements or anything else. That's usually going to be something that we're going to need to find out from the end client. The end client is going to specify, say, hey, I need my cables to be fire resistant to the 60331-2 standard. Okay, great, wonderful. I'm going to be looking at the cables, or I'm going to look at the data sheets, and the cables typically will have that marked on the jacket. It'll give you obviously the information as far as how many cores, size, and everything else, manufacturer, but it also referenced some relevant IEC or EN standards. So certainly I'm going to look at that to confirm, but that's not really part of it's not part of the 14 standard. It's a requirement that you use that type of cable. It's going to be more of a client specific requirement.
Okay, how about an EX rated box that includes IS circuit, such as wire and terminals? Can it be used in a classified area? I'm not 100% sure. Do we need EX? Do we need EX rated box for IS circuit if they're only wire and terminals?
Yeah, there's somewhat of a debate. If you have a single circuit coming out of an IS barrier per the IEC standards, you can actually downstream from there not use certified equipment. Now, if we have two circuits, so say for example, we have a little junction box that's located away from our panel. We have two circuits, a multi-conductor cable coming out of that panel that has an intrinsically safe barrier, and it's going into a little junction box out into the field. That box would actually require to be certified. Now, if we take one circuit and we take that off and we go to a simple device, and we take another circuit, come out of the other side, go to another simple device, from that box going to the simple device, we could use basically general purpose equipment. Okay. But the moment we have multiple circuits, it has to be certified. Okay.
That's an easy answer. If it's a single circuit, yes, you can do it. If it's more than one, then you have to use NEX certified.
You have to, yeah. Now that's different from installing intrinsically safe equipment in a hazardous location, because now if we're taking, say for example, your barriers are rated for zone 2, and you require that they're installed in an enclosure that meets the requirements of EXEC, which is spelled out in -7. If, say, for example, we wanted to put barriers in a zone 1 area, then we'd have to put those in a flame-proof box or a pressurized enclosure to make them suitable for being installed in a zone 1 area. Or certainly we have the barriers located in a safe area in a standard panel and go that route as well.
I'm not 100% sure about this question. Then we go to some question you sent during the registration process. Otherwise, we run very late. But see, is an inspector competent to check the correctness of an area classification drawing?
No, not generally. No. There is competency programs for area classification, and we actually teach that. It is, but I will say this much: area classification is a very difficult subject, and area classification is generally not one person doing it. It's usually a group of engineers that are coming together from various disciplines, because you have to have involvement with chemical engineers, maybe the electrical engineers, mechanical people. It's usually a group of individuals that do
the area classification. Inspector has to live with that the area classification is that, and I check against that. I take it for granted.
Yeah. Now, as an inspector, I've run into this right now, actually, where a client is saying it is this, and I'm arguing against him, saying no, it's not, because based upon, in this case, it's the Code of Federal Regulations that are based upon, well, ultimately it's based upon 60079-10-1, and there's a debate on that. So, but that's my opinion, right? I'm not the regulator, and the regulator is the person who ultimately makes the final decision.
Okay, how about, well, what is the role of an inspector during engineering, design, construction phase of the project? Is there a role for an inspector?
Yeah, I would say not necessarily, right? I would say that we all should be inspectors if we're doing design project. And the reason I say that, things like looking for X conditions, of course, that's one of the things that an inspector is going to look for. But if I'm a designer and I'm selecting products, I want to know those X conditions ahead of time, because I want to catch those particular issues when I'm designing my project. If I'm selecting products and I see a junction box that has a use certificate and I say, well, I'm going to spec that in and then we're going to populate it with terminals, don't do that, right? Get a fully certified product so you won't have this issue with people like myself coming down the stream 6 months, a year later and finding all these issues. So, I would say this, it's important for designers and engineers to understand the inspection standards so you're aware of what things are going to be looked at down the road. Do you actually need to have somebody coming in and doing inspections? Maybe you're building some equipment over time. It may not be a bad idea to have somebody come in, and I've done that for people. I just go over and take a look at some stuff, catch it before, maybe they've installed a couple glands and they've got 200 of them to go. They want me to take a quick look. I'll stop by there after work or something like that. And for a cup of coffee, I'll walk out there and I'll inspect some glands and say, hey, yeah, this looks good. Keep it up. Keep it up. So certainly, there are roles that an inspector can be involved, but generally speaking, not necessarily a formal role.
Okay. How about this one? Can you install a VFD, VSD in a breathable enclosure?
Yes. Okay. This was one of the questions for Zone 2 applications. Well, EXNR is an option, right? However, for pressurized, you can certainly do variable frequency drives into a pressurized enclosure. The issue is with drives is heat, right? So you want to try to get as much heat out of it. So you might have to incorporate things like vortex coolers, but certainly you can put drives into either pressurized or non-pressurized enclosures.
Okay, let's move a little faster. Otherwise, well, we still have a lot. Most of you guys are still with us, so good. We only lost a couple of participants, although we are running 15 minutes late.
Yeah, sorry about that.
Inspection of EXT barrier gland, many of them is not able to be splitted for inspection due to they are potted with too much casting. And many of them are filled up with too large cables.
Yes, well, absolutely.
Absolutely. So what is the point here?
Yeah, so you saw that gland that we showed earlier where it had a little cone that you would remove, and we saw some cracked compound on the inside. So certain manufacturers are actually coming out with clear, if you will, chambers that you can actually visually inspect by, you still have to disassemble the gland, but now you can actually look at it. And so my screen's actually on the other side, so I'm turning my head to look at actually what's
same here.
But yeah, I'll go back. If you go back one slide there. So if you see on the picture on the right, that's basically where it's been fully poured, if you will, with a liquid compound. On the left-hand side is basically during that pouring process. So some glands are actually designed now to where you can actually disassemble them and you can actually inspect them without removing that chamber. So
as if in the next slide.
Yeah, this is actually another issue that you will find with cable glands. So cable glands, depending on the brands, depending on the application, you can actually have what is called cold flow. And cold flow is where you have a compression seal around a bedding, could be the back end, it could be the middle portion of it. And under pressure will basically start getting that material to slide away from each other. And these are some pictures of some pretty dramatic examples of that bedding actually moving away. So we definitely want to pay attention to, cable glands if they get over torqued, or depending on how the seal is designed. Some of these glands are notoriously bad for causing all kinds of issues with soft bedded cables.
Oh, how do you or do we become an inspector? Did you, or is there any courses? What if I want to start a new career here?
Yeah, you want to do it. Great, fantastic. So yes, if you advance it, so there are more than just these two. These are the two that we teach, but there's the IECEX Certificate of Personnel Competency, and there's also what is called COMPEX. So you can go to the IECEX.com website. You can look up what is called recognized training providers, which we are one of them here in the United States. But there's other recognized training providers that can train you, and then you will get certified by an IECEX certifying body. Under COMPEX, same thing. You can go to COMPEX. I can't remember what it's org.uk or uk.org, and you can find various Compex centers, and they will provide that as well. So at the end of the day, what you would get is a certificate that would look like one of those.
Which, as you mentioned, that does not make you 100% competent. I mean, I guess you need some experience with a competent inspector like yourself before you go on your own, no?
Yeah, I mean, I took Compex. My first experience was 16 years ago, and trust me, I thought I knew a lot. And in 16 years, trust me, I realized, even though I had my piece of paper, there's a lot of things that I didn't know then that I know now. And I guarantee you, I'll know more. So
yeah, there's always something to learn. How often does the EX equipment needs to be inspected? Is there a schedule or time? Well, we have a lot of questions here. I don't know.
Yeah. The interval between periodic inspections should not be longer than 3 years. If it's handheld equipment, should be before every use. And then if we have enclosures that need to be open frequency, at least every 6 months. So, you know, bottom line, you might find that some of your inspection schedules will be shortened based upon the environment. It may be an extremely corrosive environment exposed to very nasty conditions. On the other hand, you might have some equipment that's installed in a very clean, you know, nice, pristine environment. So, but you really should at least inspect it at least once every 3 years. It doesn't necessarily mean you have to open it up and do all that good stuff, but somebody needs to go check it out and do some sort of inspection on it within 3 years.
Well, I see one last question.
Yeah, well, this
very
is
long answer, but we are running very late.
Well,
it seems confusing, particularly EX certification scheme, the certification EX profession with 2 steps.
Yeah.
Visual and detail. Is there any company hiring EX visual inspector and EX detail inspector? So is there a difference between an inspector?
Yes.
Visual?
Yeah. And this is kind of a screwy thing. And this is from my friend Estelito, who hopefully is still here, and because he asked this question. It's a good question. Under the IEC EX scheme, they've actually broken it down to 2 inspection modules. There's what is called EX 007, which is visual and close, and 008 for detailed. The thought process is that pretty much anybody with a limited amount of experience should be able to do a visual or close inspection, because we're not really opening up equipment. We're not de-energizing things. We really don't necessarily need to have a good electrical background for the most part. But the moment that we start doing detailed inspections, now we are involved in lockout, tag out. Now we are looking at wiring, internal wiring, cabling, all that other good stuff. So under IEC EX, they broke it down into 2 different modules. Under Compex, they basically have not. They say you're taking a module for power inspections and then a module for IS inspections. So they do have 2 modules, but they're broken down in a different way. Under IEC EX, the visual and close deals with both power and intrinsic safety, and detailed is both power and intrinsic safety. There are some companies that are out there that want to have their people certified just for visual and close. And that's for necessarily non-electrical people, maybe mechanical people, that they can go around and do, you know, the basics. But generally, if it's an electrotechnical technician, then they're going to go through the other module. All
right. Well, yeah, to conclude, we always get questions that are not pertinent to the webinars we are holding. So what we're interested in this or that. So you can look up our live webinar schedule online. And also you can review all our webinars like this day today and being recorded. They are on our YouTube channel. We ran 20 minutes late, guys, but let's see if we can run the last call here and have to move to the next screen. See if I can get this started. Okay. How did we do? What do you think? You know, forget me, but you know, vote for Bob.
This is my affirmation.
You know, very, very interesting as usual, Bob. You know, it really transpires that, you know, it's transparent that you are, you know, that you had 20 years of experience there, you know.
No, thank you.
Matters. There's nothing to do. Yeah. It's like going to a doctor, you know, you get a doctor who just got his degree, And put your hand in your stomach, maybe it's opening you up. You say, oh, not 100% sure. You know?
Yeah, I would say this much just in closing about the whole competency and getting your competency documents and all that good stuff. If anybody comes in and says, hey, I've got this piece of paper that says I'm competent and I know everything, I would question that because again, there's a lot of people running around with these competency certificates that have not necessarily had a lot of experience in doing it. And again, I've learned a lot from my colleague Wayne here, who's done inspections for much longer than I have, and I rely upon him. And again, I learned from customers, and believe me, I know a lot more now than I did when I first did inspections. And so just because somebody has a piece of paper that says they're competent, don't just necessarily take that in and of itself.
Okay, thank you, Bob. And as typical, you get almost all votes are excellent. Thank you, guys. We'll see you soon next month, I believe.
All right.
The rest of the day, I'm off, guys. Thank you very much. If we did not get to all your questions, we will try to do later on. Send you an email. Okay. Bye-bye.
Bye.